Hey everybody, welcome to another support video. This one is on constants of proportionality from tables. All right, so all you have to do is identify any value in the table where you have a y and an x. All right, and it's just the ratio of y over x. It's output over input, okay? So looking at the table here, it says which table has a constant proportionality between y and x of 3/4. That means the y value is 3, the x value is 4, y over x. All right, so we need something that's going to be the same as that. So when we look at this first table here, it says 6, 8, right? 6 for y, 8 for x. So this is the 6/8. So is 6 over 8 the same as 3 over 4? Yes. So that looks pretty promising. Looking at this one here, we want 3/4 for y whenever x is 1. This is 3/4 for whenever x is 3. That's wrong. This one here, 19 over 2, that's the same as what? 2 goes into 19 9 times. So this is like 9.5 to 10, not at all the same. And so the only one that makes any sense is this one here. 6 over 8 is the same as 3 over 4. Remember, it's y over x, y over x. Just compare, find the one that's the same. Okay, the next one says which table has a constant proportionality of proportionality between y and x of 10. Okay, this just means that y over x is 10. So is 20 over 2 10? Yes. All right, is 20 over 5 10? No. 20 over 5 is 4. Is 90 over 9 10? Yes. So it could be A or it could be C. Those are both possible so far. So then look at the next one. Does the relationship maintain itself? Is it constant? So 132 over 12, is that 10? No. 140 over 14, is that 10? Yes. So this first table looked promising, right? But the second value is not the same rate. In other words, y over x is not always the same throughout the table. This first table is not even proportional. The last table is proportional, and all the ratios of y over x are 10. 90 over 9 is 10, 140 over 14 is 10, and 240 over 24 is 10. So this is the correct answer. Okay, for the next one, it says which table has a constant proportionality between y and x of 1/4. So basically, y over x is 1/4, right? So this is 2/8. Is 2/8 the same as 1/4? Yes. Is 2.5 out of 10 the same as 1/4? Yes, that's the same as 5 out of 20, which is the same as 1 out of 4. So that's the same. Is 3 out of 12 the same as 1/4? Yes. Times top and bottom by 3. You can see that that's the same as 3/12. So this is the good one. It works. The others don't need to be checked. 1/3 is not the same as 1/4, and 1.5 out of 6 is 1/4, but 2 out of 7 is not. Okay, and this one says which table has a constant proportionality between y and x of 6/10? So you're looking for 6 over 10, or an equivalent ratio to 6 over 10. So 7 over 4, is that the same as 6 over 10? No, 7 over 4 is more than 1, 6 over 10 is less than 1. That's wrong. 2 out of 3, is that the same as 6 out of 10? No. If you have 6 out of 10, and we're looking at it as the same as 2 out of 3, to make the 2 into a 6, you times by 3. But then if you times the 3 by 3, you get 9, right? So these are not equivalent ratios. 6/10 is not equivalent to 2/3. So then it has to be this middle one, right? That looks weird, but let's check it, right? Basically, when you have a ratio of 0.6, what it means is x times 0.6 equals y, right? The ratio of y over x is 0.6. The constant proportionality is 0.6. So x times 0.6 must equal y. So 4 times 0.6, is that 2.4? Yeah, 4 times 6 is 24. Move the decimal 1 to the left, 2.4. 9 times 6 is 54. Move the decimal 1 to the left, 5.4. 14 times 6 is 84. Move the decimal 1 to the left, and you got 8.4. So yes, all the x's times 0.6 equal the y's. That's another way you could check it, right? Because the constant proportionality, the ratio of y over x, right, is going to be the multiplier. So x times that multiplier always equals y, right? So 4 times 0.6 is 2.4, 9 times 0.6 should be 5.4, and 14 times 0.6 should be 8.4. And it does work out that way. It's good. So that's how you do it. You can either just look at the ratio of y over x and make sure it's the same, or you can think of that ratio as a multiplier and check to see if x times that multiplier equals y throughout the entire table. Okay.